All right, I have our Coulomb accumulator code written, and it basically, the unit it uses is microamp hours, but it actually has an intermediate step of microcoulombs, which are just the same thing times 3600 or whatever. And the reason we have to do that is the we don't want to overflow a 32-bit integer. And so what we do is we count, and then every time we get, say, 10,000 microcoulombs, we convert it into 3 microamp hours, whatever the actual math is there. And so here it is kind of just working, and or not working yet. I haven't turned it on. This is turning the key on now, which I'm going to do. And right now I have the battery. I haven't actually figured out how to determine the battery's state of charge. It's microamp hours, so I just haven't written the code yet. So I'm just saying initially that it's 3 million microamp hours. And so this is our current sensor, and right now I just have it 1-to-1. So if this shows 1 amp, then the LiBCM thinks that the battery is consuming 1 amp. And you can see that we have our calibrated value here, and you can see that our 3 million count is not changing because we don't have any current going through the current sensor, so that's pretty nice. Because it means that we won't have a drift. This will eventually drift, every hour, a few counts or whatever. I have no idea. Probably a lot more than that, to be honest. So what I'm going to do here is I'm going to turn on our current source, and we'll set it to 10 amps here initially. And you can see that we are getting, this is our raw ADC value. This is the delta in microcoulombs. So it's minus 100 and 1,050 microcoulombs. And then in microamp hours, that's 29 negative microamp hours. Of course, this code is running quite quickly, so this is the delta on any one given cycle, so these numbers are going to be jumping quite a bit more. The difference there is that this is only updated, we're only spitting this data out every 500 milliseconds, whereas these raw values are just the raw values here. This was the last ADC value, the last delta micro C, the last delta micro AH, and then of course this is our accumulator, so this value is the accumulated value here. So we're down to 2.96 amp hours, for example. And so what I'm going to do next is I'm going to actually go over to our 20x current loop, which means the values you see here we multiplied by 20. And we were regenning there because the battery is less charged. So I need to make sure that at the end of the day I'm assisting. So let's see. If I wanted to do that, I need to plug this into there, and then plug that into here. So we now have a 20x multiplier. So if we set this to 0.5 amps, we should be getting the same general decrease that we were getting before. And you can see that we're in the same ballpark. Before we were minus 100,000, now we're at minus 98,900. And that's just the actual thing. So we're getting the same ballpark. So that means I did not actually flip the sensor around, which means that we can really only go down to 0 on our regen. So we'll do regen first. The limit there is 71 amps, so we can go up to about 3.5 amps here. And you can see that as we do this, if we do 3 amps, for example, and our current sensor falls off, let's auto-update this. You can see that our ADC value is in fact getting quite low, and you can see that we're removing minus 593,000 microcoulombs per loop iteration or whatever. And our pack microamp hour is actually decreasing as well. So we're down to 2.83, 2.82, 2.81, etc. So this is, by the way, just the first time I'm showing it. I still need to validate that it actually works, and these numbers do all make sense. If we go to the maximum value here, which is again about 3.5 amps, you can see our ADC is down at 6, which is about 70 amps rather. So how long can you pull 70 amps from a 5 amp hour battery? 5 over 70 hours, whatever that is. This seems like that's about that amount of time. Let me get a calculator here. 5 over 70 times 60 is 4.3 minutes. it seems like in 4.3 minutes that would be down at 0. I would buy that. Of course, again, I do need to still calibrate it. Here's the calculator just poking in. Anyway, so if we go the other direction now, I'm going to flip these current leads around. I know they're out of frame, but that's okay. So we'll plug this in. We're going to now do assist. So this is just a single quadrant power supply. So if I want to change the sign, the current, I have to actually flip it around. So now we're going to recharge the battery. See that we're charging back up. And we can actually go quite a bit higher now because we can go up to 7 amps. So 140 amps divided by 20 is 7. So if we go to 7 amps, then we are doing full assist at 140 amps. So let's see, full assist. Actually, I did have the sign backwards. And yeah, this is just one of those things where right now the battery's charging, but we're actually doing full assist, so it should be discharging. I just need to flip the sign around. So 284, yeah, this does make sense that we're increasing at about 100, we're going 2.92, 2.93, 2.94 milliamp hours. And if you look at 140 amps, it'd be 5 over 140 times 60, 2 minutes times 60. So in 129 seconds, we should expect that this value will be will go from empty to full. So whatever that is, 4 amp hours. And I can see that possibly doing that. Again, it's very possible that some of my math is wrong here. I've just kind of gotten this working for the first time. I just wanted to show it here. The key points I would think are that the microamp hours don't accumulate when there is no current flowing. So that's a good thing. That indicates that the calibration I mentioned previously and showed a video on previously is working correctly. Of course, it could also be that we're just integer underflowing. And we're discarding some small remainder, which I don't. If that is the case, which it certainly is to some extent, but if it's extreme, it doesn't really matter that much because that small amount might cause a recal every 25 hours. So if you drive the car for 25 hours straight, you might have a negative recal. If you turn the key off at all at any point in those times, you won't have a negative recal. So anyway, I'm gonna put this into the code. This is the full code running. I'm just not showing all of the debug data I normally do. I'm going to put it in the car and drive it around and see if it kind of makes sense in the car based on the battery voltages. But anyway, that's our current accumulator. And why is this important? Current accumulator is really nice for accurately telling how charged a battery is without relying on the voltage. So if you know you have a 5 amp hour battery, and if you know the open circuit resting voltage was, say, 3.76 volts, and you know that that is, say, 65% state of charge, no idea, then you can actually, instead of looking at the voltage under load, which is not constant at all, as I was showing the other day, you can instead just say, hey, look, I know the battery is this charged. It's 3.67 amp hours out of 5 amp hours right now. So it's very important to have it not have a drift, because a drift causes recals, and so this doesn't have a drift, which is nice. And then also, of course, it does need to be accurate, which that I still need to verify. So I'm not actually going to change. I'm not going to change the state of charge handler. I'm not going to change the code to actually rely on this data. I'm going to just throw it in the car, and then for a few days drive it around and see if it all just kind of makes sense. So we just kind of crossed over the 4 amp hour mark on our battery. So this is all kind of making sense, ballparky. You would think that we could charge at 140 amps that we're pushing through it from empty to full in, what was it, 2.5 minutes. That number might be low. Again, I just, at this point, it's just polishing it all off. The real thing was just doing the unit cancellation to make the math all make sense. And again, as someone mentioned on there, right, like if we were using a 32-bit processor with an FPU, none of this would, it'd be a lot easier to do instead of having to, I think I'm like multiplying by 55 and then right shifting by 19 or whatever it was to divide by 3600. Anyway, it does appear to be fundamentally working. And of course now we just need to make it accurate, which is the easier part, probably. Who knows, we'll see, time will tell. As always, thanks for watching.